Okay, time for another coding session. Welcome back. Continuing with Bangalang. And let's see. So from the last session, the first thing I wanted to just make a comment about, I think is all I'm going to do. Something to think about later. In the last session, towards the end, I added this code here. And I'm trying to remember the reason I did it. I think the reason I did it was because I wanted to be able to do this. But this is where we have an integer literal. We don't know the type of it, and at this point, it's just any number. And in our language, in Bangalang, numbers need to have a specific type. It needs to be signed or unsigned integer or a float. It needs to have a specific size. So I just decided to, in this case, nominate a type, which is what we're doing here, So if we get to the point where, because these are two expressions, so if we get to the point where we've done most of the type checking for the expression and we come back and we find out that it still is just any float or any number for integers is what we would have. And so I decided let's just upgrade those, just make them a float or an integer, 64-bit, which works great here. The other place that it also works that I didn't think about, actually let's call it any number. I can just do this now, which I think is why I intentionally did not do this here before, because I wanted that you would have to explicitly provide a number type. So if I do this here is implicitly I64. I should actually be able to do, something like this. No, you can't because you need the type. No, so I can't do that. I can't print out. I thought I could print out the type, but I can't. But so that's possible now. And I was trying to think if that's something I want or not. I'm not sure. So I'm just going to put a to-do here to come back and look at it. So this essentially provides default types for integer literals in expressions. Is that something we want? I don't know. But let's just put it through there. That should be enough for now. The other thing that I wanted to do next is round out, because we improved these here. So we have the index now. And this here, we don't like before we had to cast. The reason I had to change that was because previously we had to do something like this to cast the number, which was kind of ugly and annoying. You still could do that if you wanted a specific type. So we've got that sorted. The one other thing that I want is, it would only work here, it doesn't work here, is that I want to be able to do pointer to value. So then this should now be a pointer, so this should be a pointer. So I would actually have to go like this, dereference it, to use it in this equation. Let's have a look at that, because then we should get an error. That's what we should get an error saying like a pointer to an F32 is not compatible with an F32, something like that. So let's do this. So that's a grammar change and the ability to reference there. Let's have a look at our grammar. So it's our ranged for statement. If identifier, comma identifier. I do wonder a little bit if we should. So this expression. Dot expression script. Yeah, so it could be. Yeah, okay. Yeah, there's some improvements I think we can do to the grammar, but for now, I think all I really care about is that this identifier here could optionally have this guy in front of it. So let's just find one of those. One of these guys. ranged for, so that could be like that. I think that's right. Yeah, for, and then optionally this character. So the question mark means it's optional. And then an identifier. So now we go to parsing. It's been a while since we've done something like this, actually. Grammar changes. Where we go through the whole pipeline, you know, like fix the grammar and now do the parsing and then the type checking. It's kind of nice. So the ranged for, just checking my door's shut so I don't disturb people with my madness. When we're doing a ranged for, we have the for keyword. And that's right, we now have this kind of, this group of values, because the first one is the element, the next one is the optional one is the index. So this element here, we're saying it could start with a hat. I think I called that thing a hat. So if tokens dot peak token in the stream dot type is hat, that means we're doing a reference. And I think, so if that's the case, then I think we need to wrap this node. So this node is just an identifier node right now. And we want to wrap it in a reference node to make it a pointer to something. Yeah, this is parsing, so we don't put types anywhere. So I think up here, we just want to record that it is a reference. And obviously we need to consume that token. So where is it? Here we go, something like this. Consume the hat and record that it's a reference. And now down here, when we create the element node, we need to say like if we're talking about a reference, then we need to say, we need to create a reference node, which I think is just make node with type reference. It's probably just because it's never used. Yep. Okay, and then we want to wrap our element node with that. So we add the element node to the children, like so. And then I'm going to say element node equals reference node. So that when we come down here and add it, we'll be adding the now wrapped node. I think that's pretty much it for parsing. I mean, it's just adding, the grammar change is very simple, right? It's just adding that. So I would expect the parsing change to also be small. Type checking, if we go to ranged for, this is where things get interesting. So the thing is, like, I'm kind of tempted to split this out into two separate productions. One for the ranged one with the dot expression, and one that's just an expression. Because if we're, when we go into ranged for, we pretty much split it up, right, with type checking. So this is if we're talking about the range, and this is if we're not. So in this case, we have a start and end. So in this case, the element node must not be a reference. So I'm just going to add a check here. See, and the point in splitting out the grammar into two separate things would be that you wouldn't need this kind of check in type checking because the parsing would take care of it if the grammar was more strict. But we're doing it in type checking now. So if element node is a reference, then we've got a problem. I don't think we've got any other checks in here like this. No, so if I go to like basic for, it's probably got some. No, it doesn't, it's just comprised of other things. Identifier. Yeah, there you go. There's an example. So it's like cannot reference value from range in for loop, something like that. I don't know. Don't know if that's a great error message, but it'll do. So in this branch, you're not allowed to do it. In this branch down here, you are. So what is the implication? Let's go back to the playground. So the implication is the type of this thing should be reference. And is that it? Let's go through here. I'm not 100% on this. The best way to do this is, but so the pre-node, expression node, post node, I don't think any of that changes, does it? Well, actually, no, I think, because these are just dealing with the index. They're just updating the index. Oh, this basic element assignment node. This is where we assign actually the thing that, that's where we actually assign a value to this. This is a scope with one statement, and then we inject another statement before this one, where we basically create this value. And when we do that, we take the expression node and we grab a certain index of it. So I think the difference here is that actually we need to take a reference of that. So it's this expression node we need to wrap in a reference? No, I think it's the index node. This child node here we need to wrap. Yeah, we have an expression that we index, and once we've done the indexing, then we need to reference the result. Yeah. So this, it's this children 2 that needs to be wrapped, similar to what we just did before. So if I say if element node.type is reference, then we want to do, where did we do the other one? Yeah, kind of like this, right? Just create a reference node, and we add our, we don't want to add the element node this time though, we want to add this node. So that is this node here. It's basically the whole thing that is getting assigned to our element value. So we're wrapping that in a reference because we want to take a reference of it. Yeah, I'm just saying this over and over because I'm trying to make sure that this is actually right. Ooh. And then I guess we want to take this and assign the reference node to it. I think that's it. That's basically what we did here as well, right? Assign it to the thing we put here. So we assign it to the thing we put here. Yeah. So that should wrap that. The other thing I'm aware of is that we need to make sure that the type is correct. And I'm kind of wondering, I think that will, yeah, because we've created some AST that is not typed yet, and then when we send it here, it will get typed. So it should just get typed correctly. I think this should be all we need. Is that all we need? Okay. Well, that's the OpenGL one. Let's try the playground, the simpler one. And this is, oh. Okay, I'm kind of surprised that that worked. That should not have worked. So this is 0 to 10, and there's a 2, 5, 8, 11, which is, I think, the correct result if this was not a pointer, but it is a pointer. So we've done something wrong. Let's just see if we even come in here. Maybe I'm wrong about this. We don't go in there. What about in parsing? Do we go into here? We don't go in there either. Don't know. Oh, this would probably help. Okay, so in parsing we wrap it, which means that we also wrap this assignment, and we get value has not been declared at line 11 here. Maybe because this element node so in there it's all good. Down here, this is the only, these are the only two places that it's referenced. But here, actually what we want is the child, the thing that got wrapped. This is the actual identifier. And this is the reference, so that might be why. Okay, this is the area that I was expecting, because this here, foo is an array of floats, a vec4 is an array of floats. So then this is a float, and this is a pointer to a float. So a pointer to a float and a float are not compatible. So I need to dereference. And then we should get, fingers crossed, the correct result. Here it is, 2, 5, 8, 11. Yeah. Okay, so that was kind of a quick little thing. I'm quite happy with how fast that went. Pointer to range for element, I think we can call that done. Now I was looking into things like this. I went down like quite a rabbit hole, actually. Because when I looked into this, and I think I might have been looking into another improvement that I wanted to do. I can't remember which one it was, but it highlighted some issues with our current structure, our current code structure. And there are a few things that I have felt were like a bit more complicated than I would like them to be. So I want to kind of unify a few concepts. Reduce the amount of concepts in the code, I'm not sure a better way to say that, but just so that it's more coherent, a bit more easy to understand, and also it has a nice side effect that allows us to do more with the code. I just love that. That's my favorite. When you can simplify the code or make it more easy to understand, and then as a result, you also have like more flexible, more usable code. It's just it's a win-win. So yeah, when I went down my rabbit hole, there was a few different things that I wanted to improve. And the first thing that I approached, I was like, yes, this is all looking good. And then, but we actually kind of need this other thing first. And that happened a couple of times. And where I ended up, the first thing I want to try, if I can remember it. Yeah, that's right. I wanted to unify, because right now, I'm just going to do a whip commit actually. Right now, we have like the subscript operator. If I go back to our playground. So this is the subscript operator. We don't call it subscript in the compiler, but I want to change it so that we do. So in this case, we make an identifier node of type array, not type with the value array. Here, this is also a subscript, but this is like a slice. It's taking a slice of buff. And then here is another place where we use subscript, and this is indexing. So this here is this will be a slice, and we're indexing into that slice. So that's the three type places where we use it. So this is making a slice of this value. You can also make a slice type. So like here is a slice type. So this is actually a type node with value slice, and this one is also an index node. So these are considered index nodes. So I'm just going to unify all of that, and they're just all going to be called subscript. I might keep the naming array and slice for now because I think it's going to simplify the refactor. But maybe at some point we'll get rid of those because they don't make as much sense to have around anymore. So I think the way we might do this is if we just go into the AST types. And there should be an index for index node. Let's take that out. ST, and instead have subscript. So we need to find anywhere where we are using, anywhere where we are using index. That should be found by the compiler now because it will throw an error. And then we also need to look through everywhere where we have the name array in square brackets or slice in square brackets so that we can unify it all. There's not actually that many. I was expecting more errors. Okay, so where the node is an index and the data type is a slice. So index becomes subscript. That's a known. And the data type. So this is where I was saying, so the data type is, at the moment, is a node which has type of type. The type is just type. To say that it represents a data type. And the value is what tells you what kind of type it is, in this case a slice. So I'm going to keep that there, but instead of having the type, it's also going to have the subscript type. But this condition should still hold. That's what I'm slowly trying to get at. Okay, this will be a subscript. Again, we see slice, but that's fine. So this is node type is subscript. I think that should be fine. This is it's called in a few places. Well, that's recursive. But it's left-hand side and right-hand side expression is where it can happen. So I think we can be sure that that's not a type itself. That's the kind of thing I want to check for. Like, because previously if we said index, that was implicitly saying that it's not a type, because indexes were not nodes that exist in types. Subscript could be a type, so we need to be a bit careful of that. Okay, down here we're making some AST. Yeah, which I think should be safe just to call subscript. I hope that I'm kind of not that confident, but let's see. Hopefully, I know that can be subscript. And these are both the primary files. So this is when we're going through parsing a prime or type checking a primary. Part of that could be a subscript, which makes sense. Is member. Could be a dereference, a reference, or a subscript. I have a feeling this is really not important, but I have a feeling that these were in alphabetical order. So let's keep that. Yeah. So I think, yeah, that's right. When we're checking if something is a member, it could be a member of something that was indexed from something else. There could be a subscript operator in there. This is where we were before, isn't it? Yeah, this is what we just changed. So now this is just subscript. This is fine. This is where things get a bit interesting. So this is where I want to, this is parsing. When we're parsing and we come across a square bracket, this is where I want, where we're like doing something different for types than we are for non-types. And this is where I want to unify this. So, like I say, I'm going to keep the name in there for now. But basically the type is just subscript. So again, we want to keep this array, I think. But we just want to generally say, you know, maybe it's more like this, really. Maybe we don't need this top part, we just need to keep this part. So if we come across just another a closing square bracket straight away, that means that there's no elements in there. Which must be, you know, that's slice. Implicitly, if there's no elements in it, that's like this. The only place that can happen is when we're defining a slice, or we're taking a slice of a value, and it's kind of like, by not putting a range in here, you know, we could say 0.8, and that would be the whole, it would just be, that's a range of the full thing. But by excluding that, we're sort of saying it's a range, but it's the whole thing. So that's why we put these two in here. And actually, because I introduced this new range node, what I want to do is change this so that we actually use the range node. You know, so we explicitly say we've got a range. By saying it's nil to nil, that's essentially saying like the start and end of the range were not provided. So it's just implied what the result is, which is just the full slice. And then the range node, we're going to add to the node. So that's the slice. Now this here, this array, I guess it's an array if it's not a closing bracket, it's not a colon. So this case could be an array. Yeah, it's kind of if we come in here, so if we first we do the opening square bracket, right? We've consumed that. If the next thing we find is not a closing bracket, it's not a colon, it's actually an expression, and then after that we don't find a colon, that means we've got something like this. You know, it was opening bracket, expression, and there was not a colon afterwards, so it must be this. That's the other option. So if there's a colon, if there's not a colon, that's where we're talking about an array. If if we're looking at a type, then it's an array. Otherwise, oh, we need to move this down here. Otherwise, we just add that expression directly. Well, not otherwise. Yeah, it's an array, so we just add the expression directly. We don't put it inside of a range because that's for slices. But if we did find a colon, that means we're talking about a slice now. So we need to do something like this. We need to create a slice. And then we add this. All of it. Well, actually, I think first we add to the slice this this start expression. So the range is from the start to the end, which if we find a closing square bracket, that means that no end was provided, so we put nil. Otherwise, we'll put the end expression in. And then we add the range. I can already see a problem with this actually, but let's let's just keep going with this for now. So I think that's created our structure the way we want it. Parsing the primary. So we're going to need to do type checking and generation. We're going to need to go into those two so that they handle this new structure properly. Now that we're explicitly putting it in a range node for slices. This here, this is the code that I want to remove. So this is where we're taking, where we're resolving types, and we're like da-da-da-da-da, we found a type, we resolve it, and then down here we say like, hey, we just resolved a type. If the thing wrapping it was an index, because the parser just previously it didn't know that we're dealing with a type, so it just called it an index. Then we need to change that to be the structure that that we use for types, which was to use the type and the name. And this is the code that I wanted to cut out. But I realized that actually, oh, and then we also, if it was a slice, we also, interesting, resize the children to 1. But I couldn't cut this code out if we keep these names around, because we would need to add the name at this point. So I think I'm actually not going to keep the names. So let's just get rid of that. And we'll have to do a search and figure out what to do where we use the names. And because that was the only place where this child result is used, you know, every time we call, see normally it's an underscore, we don't use it. That's the only reason it returns 2 bools. So I think we can, so now we can just say, just return 1 bool, the second one. And here we can even just do or return. It's a normal kind of error handling. So that's nice and tidy. And this is also or return. And that's true. Like so. So that's already simpler. I like that. We're going to come back to this later. Not in this session, but in future sessions I want to... Type resolution is one of the things that I really want to improve. You know, because I got down this rabbit hole because of this, you know, a recursive struct. Whoops. A struct that references itself, kind of like this. Actually, it needs to be this to be a type alias. I got that wrong before. But see, it has a member which is itself. Currently, that's not possible. It's not handled. So we want to fix that. That's kind of why, one of the reasons that I went down this big rabbit hole. So anyway, that's that part sorted, and I think that's all of the errors. Okay, so now it doesn't compile properly. I'm not surprised, but we got rid of all the compile time errors. So in the compiler. So let's look for array. Whenever we see array, there's quite a few of these. We're going to have to fix these up. There's also slice. So because now we know it's an array or a slice because not because of the value, but because the type is subscript, we need to do this differently. There's also a check down here that it needs to be one of these subscript things. So I think we can change this to verify that it is a subscript thing. And then we'll say if, I think I'm going to make a helper, something like this. Although, yeah, because it is a type node, I want to have something like that. It's an array, so we do this. Otherwise, we do this. And we can just cut that out. And what is the, oh yeah, that's way up there. So let's add this. We'll make an as array and as slice. Because I think it's just it's not the most intuitive thing anymore. That's one of the downsides, to know that something's an array or a slice. We have is type somewhere. Is type. So let's put under that is array. And for it to be an array, it needs to be subscript. And if we go to there's always two children for a subscript node. The first child is the thing that it's a subscript of. What's it indexing into, what's it making a slice of, or that kind of thing. And then the second one, which we're interested in now, is the range that we're introducing, or the expression if it's just a single thing. So if this one is a range, that means it's a slice. So for array, we want to say it's not a range. And I think we also want to say it needs to be a type. Because you can have a subscript with a range that's not a type. It could be a value. We need to make that distinction. Actually, up here, I think we also need to say subscript. So we're checking if something is a type. Subscript can be a valid type as long as it's a subscript of a type node. Okay, and then is slice. It's basically the same thing, but this is a range. Okay, that's that. So that should be happy. Here we're saying the case is array slice. There are some other cases. And it's the case it's on a type. So I think what we need to do here is say, because an array is slice, it handled the same. We just want to check if it's a subscript. That means that it's this. So let's cut this out and bring it down here. This we need to go here, and this kind of becomes our else. Like so. Don't need that part anymore. So if it's a subscript, which means if it's an array or a slice, then we do the array or slice stuff. Otherwise, we do the other stuff for modules and structs. And we have a default. We fail if none of those work. Cool. What's next? 2 byte size. Okay, so we have like a special case up here for reference. I guess we'll have to add another one for subscript. And I think it'll be different for arrays versus slices. So if we're dealing with an array, then we have this. And if we're dealing with a slice, it's right here, then we have this. Like so. Okay, takes care of that. If it's an array or a slice, so basically we're saying subscript. Yeah, that's an easy one. Okay, so we're type checking a compound literal, and we're saying that the type node either needs to be an array, slice, or struct. So the new way to say that would be that the type node dot type, if it's not subscript, and type node dot value is not struct, then it's not valid. Because I think we were saying, yeah, if it's in one of these, yeah, if it's not in one of those, then it's not valid. Yeah, I think that works. Do we use slice still? We do. We don't use strings though, looks like. Okay. That's that one. Actually, maybe I'll close some of these. Got a lot of files open. All right, what else we got here? Oh, we didn't really complete this. So we don't need a special type branch. This is the parsing that we fixed up earlier. But we can actually simplify it a bit more. We don't need that branch anymore. And we don't need a set of value because we're not using those. Okay, what else we got here? Not array and not slice. So basically that means the type is not subscript. Array or slice. So we're talking about it as subscript. And this is array or slice. So again, we need to be careful here that when we change these, we're referring to types. If we're referring to types, then this kind of change makes sense. Oh, well, it must always be types. Because an array and slice, those square bracket terms, they were specifically for types. So the thing we need to be careful of now is that the context is that it was a type. Because there could potentially be some places where I don't know if it's a type node or not. But then if I establish that it's one of these, then that implicitly says it is a type. But this is not implicitly saying that it's a type. So that's a difference that we need to just keep aware of. So here we know it's a type node, and we're saying if it's an array. So what's the context here? Generate assignment float array. So this is, we've already established that it's a subscript. The left-hand side type node, which is the 5th, this one, type node, which I think is, yeah. So I think I think that's right. If we're doing something like this, then we just need to switch to isArray. Here's another one, actually. Could be more efficient to call this one as installer result, but I don't think it's a huge deal. Okay, this is something where arrays and slices, we do different things. It looks like arrays and slices are the only options. Is this generation? This is type checking. It's a compound literal. I'm just trying to decide whether there's... Okay, so we do have something to say, like if it's neither of those, then this is an error. So I think we'll just change this to be, if we're not looking at a subscript node, then we throw this error. And this is how we decide to do things, whether it's an array or not, an array or a slice. So array goes there. Oh, slice is nothing, so we'll just go like that. Like so. Okay. Type checking identifier. It's also type node. Type check swizzle member. Let's just be safe and use the isArray. Like so. GLSL, so this is generation. So arrays and slices, we do certain things. I'm not sure why we only exclude these. I feel like there's a bunch of types that are not valid in GLSL. But let's leave this for now. I think we'll come back to it later. And do a proper pass on GLSL, because right now it's like, it kind of works. I mean, it works for the cases that we are trying, but I think there are a lot of things that would not work properly. Okay, so this is what we do for arrays is this. What we do for slices is this. And if it's neither of those, then we do this, which of course does not handle arrays and slices anymore. Okay, I think that looks good. What's going on here? Where are we? So we're declaring something, it looks like. Oh, we're in an assignment, we're type checking an assignment. We've established it's a declaration. Declaration of an array. And we're converting it to a slice. Because we're using a memory allocator. So a memory allocator, like this. This is a dynamic memory allocator. So if we allocate something on the heap, this looks like an array, but actually it returns a slice because we need to keep track of the pointer, and a slice is a pointer and a length. So this is actually a slice, even though this type is an array. So yeah, so we have an array type, and then we need to convert it to a slice, which is done a little bit differently now. So I think we need to say is array to confirm that it is an array type. And to convert it to a slice, we need to wrap the expression. This is the expression here, which we keep for later, looks like. We need to wrap it in a range. So we make a range node. There must be appends around here. There we go. So to the range node, we append this expression. Or do we? No, because we're changing it to a slice type. A slice type. Maybe I'll keep this guy open because this is useful. When we parse a slice type, then it's going to be closing bracket straight away. So this is the structure. We need two nil nodes. So we make sure this range with two nil nodes. And so we resize. I don't think we need to do that anymore. So that's cutting their length off. That's what it was doing before. I think we just need to say that the second child is now the range node. Yep. I think that should work. Okay, what else we got here? This looks like we're creating an array node. So actually this is a subscript. First child is the thing we're making a subscript of, and the second node is the expression. For arrays, the structure doesn't really change much, just that this type is subscript now. So that's fine. Again, we have array slice handled together, and then there's like module instruct. So I think we're going to need to do if the child type node is a subscript, else we do what we were doing before, all of that stuff. And if it was a subscript, then we have this big old case here, which we put here now, and we take that out of there. So it's just handled a bit separately. Okay. That's that. Slowly making it through here. Here we're making another array node, so we established that the structure is the same, except this is just now a subscript node. Okay, container, this is, so we want to just confirm that this is an array node. So let's use isArray. That should take care of that. Contains allocations. This is determining whether an expression contains allocations, because if it does, we need to do a little bit of extra work in the assembly. So here we're just, I think we can just do isArray. I don't see why not. Well, I'm sure we're going to have some. We're going to break some stuff. We're going to break some stuff. That's definitely going to happen. So if this type node is an array, we do this stuff. Case array. So when we're making the type name, yeah. So again, we probably just want like special subscript area. What we handle based on whether it's an array or not. If it is an array, then we do this. And if it's a slice, then we do this. Voila. And then we can take array out and slice out. Perfect. Is there more in types? Yeah, down here. Yeah, I thought there was another name procedure. So this is going to be very similar. Subscript if is array. Then we take the array code and we put it up here. And the slice code goes up here. Like so. This takes care of that. Looks like the only two cases we supported are array and slice. So I think we just want to say that, and but we also want to return that so maybe I'll actually do this and we'll keep just the array false and put that in there. And then this ends up in here. But it's no longer a switch. It's the isArray business. So if it's an array, we do this. If it's a slice, we do this. There we go. And if it's neither, then we throw the error. Cool. Get length location. This looks very similar. Looks like it was right after it. How did I do that? Ah, that else was like there. That was the structure. Okay. So for array we do this, and for slice we do this. And then we can cut all that out. Unsupported length location. Yeah. Bit of a copy paste error there. But I think that's right. Oh, but we return immediate 1 apparently. Okay. Yeah, that looks good. This does not look so good. Oh, it looks like I accidentally moved that down here, basically. All right, I think that's that. Just checking if that's an array. Do that the new way. And here, looks like we're creating some AST which is an array, so that's just subscript. And that's it. Is there any, well, there's quite a few references to slice still. So this is creating a slice. So that needs to be subscript now. Instead of putting the expression directly in, we need to wrap it in a range node, like so. So we make a range node. But there's only one thing in it. So it was making a slice and it just had one child. Ah, that's the thing, that it's a slice. Well, that's the type. That's a type. So it's a slice. Right, yeah, that makes sense. So it's a type. And I guess it didn't have anything else. But now I want to add a range node as the second child. Which yeah. That should take care of that. Here's somewhere where we specifically do things with slices. So we can say if it's a slice, if type node is a slice, do this. Otherwise, we can have the switch, the rest of the switch can go in there. I mean, it feels a bit silly actually, because to keep it as a switch, but whatever. Let's just keep things simple for now. An arrow factor. Okay, so if we're not a slice, type node, subscript type node, generation. It's not a slice. Does that mean that it has to be an array? Like the only two things you can... No, I think that means that we're creating a slice. I don't know. Let's not do anything that can cause too much trouble. Let's just say, oh, so we're saying it's not a slice. I feel like that could be is array, but let's just keep it like that for now because that's the exact translation. Less chance of things going wrong. Whoops, slice. If it's a slice, then we do that. Oh no, I want slice. And if it's not a slice, so if it's not a slice, that's saying is array. Was that is array before? Yeah, equals array. Okay. Type node equals slice. So let's just say is slice. Oh, I hate how it keeps going back to this now. If it's not a slice, well, it shouldn't be a slice. Not slice, yeah. This slice. I'm glad I made those helper functions. Again, is slice, right? Yeah. Sometimes when I do too many of these things, I don't look closely enough at them. Okay. Is, yeah, is slice. If A is a slice, and down here it's B is a slice. A slice of U8s, that's what a string is. Okay, we're getting there, we're getting there. It's mostly just checking whether something is a slice or not. I imagine there could be some code in here that's like trying to deal with the structure. That's right, I don't think we fixed that. We need to go through type checking, primary type checking, and primary generation to make sure we get that fixed. Because we changed the structure in parsing, but I don't think we did it yet in type checking and generation. I don't think we handle the new structure yet. I should probably copy that because we use it so much. I think there's only one more usage of it. Did that a bit late. Slice of U8s. It's talking about a string also. Couple more of these. So this is where we're talking about a slice. So we need to extract that. Oh no. Hey, I do get to use it still. Okay, get this switch, put it in here. And we get the slice case, and we put it up here. This is probably something similar. It looks like only slice is supported. Oh no, struct. Okay, I think we need to keep that above, so so if the type node is a slice, this is the slice case, and the rest of the switch goes in there. Cool. And here's another place where we're creating a slice type, slice of U8. So yeah, this is a string. So this is actually a subscript now with this range node. Add that as a second child. Okay. I think that was all of the, okay, that's all of those. So now, like I said, we have primary parsing that we changed. So let's check our type checking primary. Yeah, when we go to subscript, so this was assuming that the second child of a subscript is an expression, because I think previously it was there would be like the subscript node used to be called the index node. The first child of that would be the thing we're indexing into. The second child would be an expression, and then optionally there would be a third child, which was the second expression in the case of a range. So I'm wondering what the easiest way to handle this is. I think if we say start expression node. I don't think we don't have that saved anywhere before. It depends on whether, so this could be a range. If it's a range, then we get the first child of that range. So actually maybe a simpler way to do this would be to say we default to this, which is what it was previously, and that will work for when there's only one. When it's not a slice, this is the expression. Otherwise, we need to get the first child of it, and then anywhere where we have this, node.children1, that's the expression node. I think this little bit of code here is, it's only for arrays, so so that's only for the case where we don't go in here anyway, but whatever. So this here where it's saying is the length of it 2, what that basically is saying is that it's not a slice. And what do we need to, so I think we're saying that it's not a range here. The second thing is not a range, so we're dealing with just an array. And this is when we're dealing with a slice. Yeah, because we're making the slice stuff, so that sounds right. But this is not. So I could say end expression node is pointed to an AST node, but it's nil, unless we're talking about a range, in which case it's the second child. Instead of this is what it was previously. So this is the end expression node. Okay, I think that should cover it. I hope. Let's see. I think we can do probably something similar to this in generation. Generation of a primary. I've been so slack on the GLSL generation, and I'm going to continue to be slacked because a lot of this stuff just doesn't apply. Primary string literal. This looks like it. Yeah, subscript. Okay, so here we do save the start expression node. So I guess we want to change that to be like that. Yep, depends on whether it was a slice or not. And then somewhere there's some code with end expression. Here it is. So this will actually be one 1, 1. That's the end. This is the range, and this is the second child of the range, the end expression. I think that should be it. What happens if I run it? Probably crashes. Yeah. Why am I not surprised? We're already an hour 14 in, so hopefully the debugging does not take too long. Okay. So we have a range. because I do that first. Let's just do that. I think that's maybe simpler. Okay, so we're auto dereferencing and our type node is null. We're doing a subscript. If I can get a bit more information about this. So we're doing a call, the procedure node. So it's I to a vec4.size buff slice. So then we go into an expression, which is one of the parameters. It looks like it's the first parameter. Yeah, the first parameter of this, so vec4.size. Vec4 is a type. So we go into type check primary. It was a type node previously. It was a type node previously. How do we handle types in here? We do this. If it's an enum type, we do something. Anything else at the very bottom? You can untype. And if it's a type, you shouldn't recurse. Just trying to think if it's a... Because we might be able to just say, like, you know, if is type even. If we're looking at a type. I know type check type sounds pretty weird. But I might do that and then just return, and then we don't need that condition. And type check type would just, the only thing in there is this, which checks for duplicate members in an enum, which we should do for structs as well. So I'm going to copy, wait, this is type checking. Primary. I'm going to make type, so type check type. And go like that. Can take out all that. Yeah, so I think we can do this for structs as well. So it looks like we do it for all the nodes. Yeah, I think that's right. I think that should be fine. I guess we'll find out. So now that... Oh, we need to pass the context in. Do we actually use the context? We don't. Oh well. I think this is still where we were. I kind of thought that would fix that. Yeah, so we're doing the I2A, and is it still the first parameter? We go and we go to type check the primary. Ooh. thought it would know that it's a type. Oh, it's size. Yeah, so then we go into here and it's subscript. But wouldn't it know that it's a subscript of a type? Like when we go into auto dereference. Yeah, it's a type node. So it's a subscript. It's a subscript node. And the child is a type node. So I would have thought is type would return true. Right? If node is subscript, and we go to the first child is type. Oh, I have all return. I think it should actually be do return like this. We always want to return after doing this. That's probably what it is. Okay, a different error. Fantastic. So I think basically what we're trying to say here is that this is only valid for type. So if it's not a type, no. Yeah, we're asserting that it is a type. For type name, probably there's one here. I don't know if there'd be any others like that. Okay, interesting. U8 and U8 slice are not compatible in core strings. Let's have a look at what we're dealing with here. Core strings 68. So it's taking buffer and it's taking a slice of it, so this should evaluate to a slice of U8. And the return type is a slice of U8. So why does it think that one of these is U8? And it should be the very top level one. So what is the first? The first one, because that's the one that's wrong, is type node. So let's actually put a breakpoint here and see what we're dealing with. So type node is U8, and expected type node is subscript U8, right? Subscript U8. So what's happening here is that we are, got myself lost. Let's close some more of these. So what's happening here, if we look in strings, is that we're taking a slice of something. So the type of this, the type of this expression should be slice. It should have the same type as buffer actually. Well, if buffer is a slice. So that should be, I believe, type checking a primary is what's responsible for creating that type. If we go into subscript here, so if node.children equals 2, yeah, so that was where it would not have been a range. See, we assign this data type. Now we assign this data type. Should be a subscript. Maybe I'm missing something here. Was that anything to do with the start and end expression node? No, it's yeah. I was kind of hoping that I would stumble across the right point, this point in the code, but I think that's going to be hard to find. This is just bounds checking. So this is type checking the expression. This is type checking the end expression. This should be the because we need to no, I think that's right. Yeah, the first child is the thing that is a subscript of. The second child is the empty range to mark it as a slice. I'm not sure why that has caused trouble. So we have this slice. If we go to parsing of the primary, let's have another quick look here to make sure we're doing the right thing. So in this case, we have our opening bracket, so we set it to be a subscript node. Then we have a colon. So we add, yeah, I don't think we did this right. We need to make a range node. If there's a colon, we need to make a range node. And add nil to the range node. Then we get the colon. Then we oops, I'm getting confused here. Then we add the end expression node to the range. And then we add the range to the parent. Yeah, so we wrapped that in a range. That's what we got wrong, I think. We weren't doing that. Okay, a different error. That's good. That's good. So is slice type is null, contains allocations. So it doesn't have a type. Because it is a type itself. Node is a type. Right, because we said index here before. Is there anything here? I wonder if there's anything here that... Well, this says that it's an identifier. This says it's an index. So I think basically it can't be a type. Return true? No, return false. If it's a node, there's no allocations. I mean, a type, there's no allocations. So for types, we don't need to do this stuff. Hopefully. Whoa. That looks correct. Okay. No, I wanted the OpenGL. If we go to threading 146, types U64 and I64 are not compatible. 28. This is column 28. So it's CPU info. So if I go to Linux read, it's expecting an I64, but it's getting a U64, which comes from open, which returns a U64, but it's returning a file descriptor. I guess because I changed a lot of things to be U64, but I kept file descriptor as I64 because -1 has a purpose. So I guess that needs to be I64. So we need to cast, yeah, kind of like this, I guess. We need to cast the result. Or we need to discard the type of the result. So I guess we'll call that file descriptor. Okay, it's not happy. I guess it's a subscript. Yeah. Huh. I'm surprised it could be such a simple condition before. So we just validate that that is a type. Hey, OpenGL's working. Let's make sure we get rid of this window. Causes issues. We're an hour and a half in. It was quite a big refactor. Probably seems like we got not much out of it. We haven't got much out of it yet, but it will come in. It will come in handy. Let's do the health check. Looks like we've got some broken tests. Oh, yeah, lucky I checked that because it might not be a reference node, right? So it kind of depends. Maybe we'll do, if it's a reference, then we grab the first child. That's the element node. This here would be the reference. That's what we need to check against reference. So let's say if that is a reference, that's no good. The stuff in here is fine. Down here, this is correct, but this needs to be this. Yeah, so they should handle both cases when we're talking about a pointer and not a pointer. So then this just needs to be element node, not the child of element node. Okay. Let's check in our health. This is running a test suite, by the way. Oh, and all passed. It's a very incomplete test suite, but it caught that, you know, it showed value already. Okay, so that's where we're going to leave it for now. And coming up, we're going to get stuck into some more refactoring. So I hope you like refactoring. Hopefully we can get like something else, like check off something here as well as getting some more refactoring done. But yeah, there's a couple more aspects that I want to do. Right now, there is a special type of node that is a type node, which refers to types. I kind of want to get rid of that also, because really they're just identifiers. So I just want to treat all identifiers the same. Some of them happen to be types. But the way to know that is just, I mean, there's only a small finite set of real solid types that the compiler knows. They're a known small set, and then user-defined types like structs and enums and stuff like that is just a combination of those known types, you know, or aliases to those known types and things like that. Anyway, we'll get into that next time. This has been a long one. Lots of refactoring. But yeah, thanks for stopping by. Have a good one. Ciao for now.